welcome everybody to this month's Melbourne, Xamarin and Blazor Meetup. Going to have some pretty cool stuff from Glenn shortly. Few announcements just to get us started. First of all, thank you to our sponsors, Melbourne App Development and Microsoft. In terms of what's coming up shortly, tomorrow-ish, depending on time zones, and for the next 3 days, there's Xamarin Assemble, which is an online conference. Traditionally, it's been in Argentina, but now it's everywhere. So a lot of cool presenters going on there. So head over and check that out. I sure will be. It's free and no session limits or anything like that. So no excuses. Another big announcement that's happened recently, although I'm guessing most people are across this, Apple Silicon is coming. No more Intel chips in your Macs. Exciting thing about this, as far as I'm concerned, is all our iOS apps just start working on new Macs automatically. Hopefully that'll be good. An announcement of a new podcast that's just come out. It's been out for about a month now. The Null Pointers podcast by Gerald Sly, Stephen Tewison, and Mark Allabone. They've all been quite active in the Xamarin community for a few years, and now they've just started up their own podcast. So it's mostly Xamarin content and a bit of related mobile and .NET and tech stuff. So I highly recommend checking that out. A few job opportunities going around at the moment for anyone who's on the hunt. Matthew from Mfractor asked me to put the shout out. It's with some Brisbane-based analytics company, and it'll be working on Xamarin Forms for UWP, Android, and iOS. I don't know any details really beyond that, but if you're interested, get in contact with Matthew at mfractor.com. The other one is working for Clinton Rocksmith. He's looking for iOS native developers and also some DevOps people. So get in touch with Clinton through LinkedIn or have a chat with him. He's here tonight. The other thing, we're always looking for more presenters. So if you've been working on something cool recently, or you know stuff about Xamarin or iOS, Android, .NET, anything kind of related to that, let us know. Get in touch with Kim, Rod, or I, and we'll get you lined up with a spot.
I should say there as well, also if there's anything anyone wants presentations on, we can probably reach out to people.
Yes, thank you, Kim.
If anyone's got any ideas of something they would be interested in, let us know as well.
Cool. Alrighty. We're about to get into our proper presentation now. Tonight, we're very lucky to have Glenn Watson with us. He works on reactive UI and is also a Microsoft MVP. So if you're into any of that RX kind of stuff, chew on his ear because he's got a lot of good knowledge to share. Tonight, he'll be talking to us about source generators, which is a new C# feature, which I know almost nothing about. So I'm going to stop sharing my screen now and hand over. Welcome, Glenn.
Welcome.
So let me share. I'll start off with, how many people here have heard of Fody out of curiosity? Have people used it?
Yep.
Yep.
So let me quickly, I'm just going to share my screen and we'll just go through how Fody roughly works because it's a parallel to source generators. Source generators is just easier, right? So is that big enough text? You want me to zoom in a bit?
Yeah, give it a zoom. Beautiful.
So if we go into, like Fody, what it does is it basically reads through your source code after it's compiled. That's an important distinction. So it reads your IL code, and then what it does is modifies or generates existing IL code. So let's find an example, Weaver, as they call them. So I don't know, property change or something. Or property changing, that'll do.
Probably the one we all use.
Yep. So this one's for, doing property changing. So it has, do not modify, do not notify, and, like implement the property changing. So you put this on top of a class. And what Fody does is it comes along, finds that property, and then goes, all right, I'll change it over, right? So, but let's have a look at the actual code for generating. First off, it's like a huge ass, big long list of code here, right? Which can be simplified, but it's fairly massive. And what it kind of does at the end of the day is it does the, let's have a look for this. It basically generates IL code. So it's basically assembly code. So I'll swap gears for a second, jump to the reactive UI one, because that's a little bit more direct with the way it uses Fody. So if we go down to Fody and we just go into the module weaver, and so imports all these extra assemblies in for you. And if we go into the weaver itself, at the end of the day, it goes through, it does fairly common reflection code. So it goes through every class that matches the target, and then goes through all the properties available. And then what it does is it does this IL stuff. So it emits IL code, and, like it's very hard to read, right? It's not obvious what's going on for a new user if they want to make their own weavers effectively. So you have to know, an argument, you have to pop the stack, you have to dupe stuff, you have to, do a branch, and you have to pop that, and you have to get the, a body of a method, and then do a return, and, then call a virtual method, and then you have to get the instance of that method, and it's just a mess, right? So it's not friendly for users to jump in and, sort of like use it straight away. But it's effective. It's good in terms of, you can kind of get a lot of manual code you'd have to do yourself, like an notify property change, and it generates all those for you, right? So it does a lot of nice work for you. And it's the only way we've been having at the moment to sort of like generate that code automatically. So Fody will sit in your MS Build project. It'll go off and sort of like get triggered after the compilation is done, and then modify code for you. So that's the way it kind of works. But let's go into the new dangled feature called source generators, coming in C# 9. So it's a preview feature, but it's already, you can already code with it at the moment. And let's get started. So I'll swap the screen over to my Visual Studio instance. Cool. So can you guys see the browser there, right? Sorry, the IDE right there. It's big enough.
Looks good for me.
Okay. So the first thing you have to do to use a source generator, you have to be in preview. Has to be both Visual Studio Preview, and also the language version must be preview. But let's make one for, I don't know. The first one I'll do is like a read XML files in the class. So let's make a quick XML file in here that we want to generate a class from. So I go in here, I'll generate a quick XML, and we'll call it my classes.xml. We'll put a root instance here called generators maybe. And we'll just basically generate a class from some very obvious sort of code. So we might have property, and we might give it a name, and we might give it a type, and we just make this based on C#, right? So I'm just going to create two of them, one on a string. And we'll make this one a simple string objects. And then we'll do this all over again with a class 2. So what I effectively want to do is want to read any XML files in my class, in my project, sorry. And I want to, if it's got a class property in there, go in, find the name of it, and then generate properties from the property 1 to ints. And I could call this, just to make it a bit unique, So what we want to do is now we want to make a generator that reads this XML file, right? So I'm just going to add a normal class library in. We'll call it source generator. XML generator. So fairly obvious name, and I'll just bring up my IDE where I did this code previously quickly. And with this, also we'll have to do preview, but we can keep it pretty much the way it is otherwise. So we just set up our Lang version of the preview that says now use C#9. And I also just need to bring in the Microsoft Code Analysis NuGet package, which contains the source generator. And the code analysis toolkit is part of Rosalind, and it's been out for a while now. It also contains things like the code to generate analyzers and things like that. So analyzers are a feature that inspects your code, finds problems with your code, and then gives you a little yellow bubble next to your code to say, hey, this is a problem, fix it. So that's effectively what an analyzer does. And the source generator hooks into that mechanism. So it treats it like an analyzer, but it also just does the generation for you. So what we'll do is we'll create a class in here called XML generator. We'll change the name of our class to match. And we just want to derive off I think it's source generator. Yep. So we just derive off source generator, and we'll just bring that in, and we'll just put an attribute above there saying it's a generator. So this gives basically the C# analysis the ability to know this is a generator. And the generator basically has two methods on here. So one of them will actually execute the source generation, and the other one allows you to initialize based on information about what classes you want to generate from, that kind of thing. So that'll become in handy for when we do an iNotify property change, which I'll do next. But let's focus on sort of like the XML generator for the moment. So we have a source context. So a source context is basically reflection information. So it'll provide information about all the classes in your project, also any additional files in your project, so you can extract that extra information out. So in this case, we're interested in getting all the files and ends in extension of XML. So that context has sort of like our compilation, which is our reflection, but we're going to use the additional files token there. And what we're interested in is just files that end in .xml, right? So we're interested in XML files, and we just need to import that in. What am I doing? Misspelled it? Yep. And we just want to ignore case, right? So we'll just do, doesn't really matter, but I'll do that one. So we've got a list of files now. And let me, is that too big for you guys? Because we're kind of having to scroll a bit there. Do you want me to kind of put it all on one line for you so you can see it a bit easier?
Yeah, that's nice.
So we go for each file in that file list. So these will be all XML files. And then we just want to get the file text, right? So it has the ability to get the text of a file, and we just want to convert it to a string. So this is a source text file, but you can just convert it easily to a string. And then we basically want to just do an X document, right? So this is just standard off-the-shelf C# code. So an XML document, what we've been doing for ages, nothing fancy. And we just read in, parse it, and then we just go through each class element in there, right? So we do we just grab all the elements that match our class. So if we go back to our XML file quickly, we're going to match that's the root element. We're going to match each class element. So that's what we're doing right now. And then we'll create a string builder. So here's the nice power of source generators. You're actually dealing with source code now. So I'm going to create just going to generate a class using whatever method you want. You can use codom, you can use Rosalind, you can just use plain text like I'm doing. It's fully flexible. As long as you get source code as text at the end of the day, it's fine, right? So we're just going to add a namespace in here. Oops. Let me rename that. And we're going to add just the normal sort of stuff you do. we could probably have done this with a, as long as it's text, we'll add a ending bracket. And so what we're interested in now is we want to generate a class, right? So we'll do a and let's call it, hang on. Let's get the class element, get the attribute called name out of it. This is where the we're going to get a huge long line, so hopefully you can still read it. Actually, that's probably all we need. So we get the name of the object we're interested in generating. And have I added too many brackets? No, I just need that. Okay, so we've put a partial class. We named it from the XML file. And now we're just going to append another starting bracket. So it's just basically C# code. Now we're going to go for each of our properties, right? So and now we're going to match our property. So if we go back to our XML file, you can see in here, we're just going to match these guys. So we're just extracting that out. So now we're just doing normal code, right? So it's going to be a public, it's going to be the property element. This is where I might actually make this just a concatenation so you can see it on the screen actually. Because then I can just put it on new lines. So we're just going to grab the attribute that says the type, and we're going to grab the value of that. And then we're going to do a space, and then we're going to do the property element. We're going to grab the name of it. And then we're just going to do our normal getters and setters, right? So we just append that in there. So that'll be all our different properties. And then we get out of our current class. And then now we get back to outputting a class for this, right? So what we need to do is we need to have everything in a source tech object, which is pretty simple. We just basically tell the generator, hey, generate some source code for us and pass the tree for us from the code we generated in that string builder. So it does all the fancy work of generating all that OIL code for you from this source tech object. So if we go into here, we pass in our class text, and we might have to sort of like, I didn't want to put anything. Come on. Hide. I'm going to just bring in the class manually. It looks like there's been an exception in the in Visual Studio that's preventing it from doing the completion on me. So we got the source text now, and now we just want to tell Rosalind, hey, add this into our project for us. So what we want to do is just add a we want to give it a file name. So I'll just copy one I've done earlier. So we're basically telling it, add the source code into our project and get the file name without the extension. So it's going to be myclasses.xml, but without the XML, generated.cs, and we pass in the source text. And now we want to tell we have a little demo project here. We just want to tell it about our project so we can test it out, right? So what we'll do is we'll, first off, tell it about the additional file, right? So we want to have an additional file so it knows to go off, read this in. And then the other thing we want to do is just do a normal project reference, bring it in, and we'll actually let me grab those and I'll just do it the old-fashioned way. So we just add a project reference in, which will bring it in here. and it seemed to have screwed me up a bit. So what I'm going to do is grab that. So we've got this project reference, just a normal project reference. And we're just going to tell it that the output type from that project is going to be a analyzer. And we don't want to reference the output in our current project. So those are the only two extra properties you need to do for a, if you're just including another project in. If you've got a NuGet package, that data is automatically included as part of the NuGet package. So in theory, if you're going to do a NuGet version of this, you're just going to have a package reference. And you just going to include, you know, like my source generator .xml, and you'll do the private assets equals all. And what that says is don't include the DLLs in my output. So if you're doing this from, you know, like something published on NuGet.org, you know, like say someone's generated a iNotify property change one, you want to use in your own project, that's what you need to do basically to include a normal one. And if you're doing a project reference, if you've made your own, you just need to make sure you put it as an analyzer and don't include the output. So, all right, cool. Let's make a main method. So, you know, just a standard C# main. And there's a little bug in it at the moment with the preview version where it's not quite bringing IntelliSense. In the earlier previews it was. So basically, let me kill that. That was paint. And we're just going to do okay. Just going to tell it about the XML file there. Got it. Cool. So now we can actually use that class, those classes that we generated here. On the final version of Visual Studio, you'll be able to use IntelliSense. So basically, whenever you, it will basically compile in the background automatically for you every time you make a file change. Or if you change the file, whatever, it will generate the new classes for you, which is actually happening behind the scenes. But at the moment, there's a bug where IntelliSense is not picking it up. So we just have to be sort of like, so we go into CSV generator. So we have to match the namespace we put up here. So I'm doing CSV generation. So I'm just going to bring that in. And then we're going to bring in the my class one. So we'll do that. So at the moment, our big problem is we can just use them using up here, by the way. Okay. And then we'll do instance.property1. And I think we made this one an int, right? Yeah, so we'll make that 25. And you know, instance.property2 is equal to blah, and then we'll just do a console out, right? And we'll just do, you know, instance.property2, which is a string, plus instance.property1. Now, in theory, if I've done this right, it'll file. So let's see. Well, it doesn't seem to know about it. So let's do some debugging, which seems to be my what. So we brought that in.
That using you've got there, was it meant to be XML generator rather than CSV generator?
No, because we put that in here, right?
Oh, okay. Sorry, ignore me.
So we got the code in here. I might even bring in my prior example in a sec. And so here's one I produced earlier.
Was there a missing bracket in there?
Whereabouts?
I think you didn't have a closing squiggly. Maybe you need one.
Oh, yeah.
With the namespace, I guess.
Yeah, that might be it. Still doesn't like it, but I've got a one prepared in another window, so I can always just bring that out. Yeah, I'll just do that. Hang on, I'm going to swap my share. and I'll swap it to the other one I prepared earlier. Basically the same thing. So if I compile that, or recompile that, it's worked, and now I can just sort of like, you know. So if I do that and I run it, you guys probably can't see it. Can you see that output window?
No, didn't see it.
Chuck on the console read line.
Yeah, I can do that. But let me just do a new share for a sec. And that was the output from the program. So, but yeah, I find the IntelliSense a little bit flaky at the moment, but they've got a bug in it, and I'll probably fix the next version of Visual Studio Preview. So that's an example of doing one for a just generate from XML file. Everything becomes available. And the other thing is, if we now use this in another project, it'll probably be fine, right? Because it's already in assembly. So if we did another app, and we just did, let me swap the share back to Visual Studio, and I did source generator 2 or something, and I just include that other project we generated the stuff in. So we did it in the test generators. Now if we do, there you go, it's picking it up now. Maybe not. But yeah, you get the idea. So this feature is quite useful in terms of, I'm suddenly not dealing with, you know, that Fody example doing the IL. I'm just dealing with actual source code now. So pretty basic source code, nothing really fancy. I'm just really reading an XML file, you know, fairly off the shelf stuff. So let's go on to a bit more of a in-depth example. So let's kind of like do an I-notify property change one maybe, if you guys are happy. Does that sound reasonable? Any questions so far?
Glenn, I've got a question.
Yep.
And anyone else can chime in. So tell me what's happening here. You lost me a bit. Tell me what's happening here. You're not actually generating the source code. You're sort of generating and running the source code. Is that right?
No, I'm generating the source code. So in here, I'm going through and reading every XML file in the project. So I'm saying grab all the XML files, grab the text of the XML file, load it up into a standard X document, go for each, in that text file, grab each class property or class element. So if now we're doing the classes, so we're grabbing from the XML file all the classes, and now we're going in and putting in the namespace to see if we generated. We're creating a partial class based on that name. And then we're going for each XML property in here called property. And I'm putting it out as a public. I'm grabbing the type attribute from that property. So I'm grabbing that guy there and putting that in the text. And then I'm saying grab the name. So I grab the name. And then I do just the standard getter and setter. And then I put that into, it does all the fancy work of generating the IL code for you. So this step, if we look at it, basically goes in and generates a sort of like the IL equivalent of what Fody did for you. So it gets rid of all that complexity for you, puts it into an object for you. And then you say, I want to add to the current Rosalind instance, you know, the background of generating the code for your project, just add in the source code in a file for me called same name as the XML file generated.cs. And then you add the source text in here. So then behind the scenes, if we compile this and look at it in IL Spy, which I'll swap the share to.
Wait, can I interrupt you there, Glenn?
Yep.
Is the source code actually outputted, or are you generating the IL code and you're running the IL code?
It generates the IL code from your source code.
Right.
So it's a nice hybrid world where you don't get to see the source code, but you get to it's kind of like Fody in that sense. It's kind of like allowing you to do a lot of boilerplate code, but it's a lot simpler to code up, right? So you're no longer doing assembly code, you're doing C# code. And it hooks into the Intellisense compile. So every time you compile, or if you're getting Intellisense background information, it will automatically compile every time for you, and it hooks into that system. So we go into my source directory, and oops, wrong one. And just go into whatever project folder that is. Let me go back to here for a sec. Okay, I'm going back to Fody. So if we go in the bin directory, just go to the net core and we'll just go and have a look at the executable. And of course, it didn't want to read it. There we go. So now we go into CSV generator. It's generated that class for us with our two properties in there from an XML file. So we had an XML file that had a name of this, a property type of this, a property name of this, and it's gone off and generated for us, which has allowed us to access those properties.
There's a question in the chat from Doug, which I think you've kind of just answered anyway.
Yeah.
So he said, so does this mean that the generated source code is never persisted back into the project?
It gets persisted back, but you don't see it as a project item. It's automatically generated like a Fody.
So there's no file anywhere with a .cs extension?
Not normally, no. As far as I can tell, it doesn't put something in the OBJ directory or anything like that, as far as I can tell.
But I guess what matters is that when you're writing it, you get to think in C#.
Yeah, that's
even if it
advantage.
does get end up being stored on a file as IL.
That's right, yeah. So it allows you to do a lot of boilerplate code. Like, for example, one really useful area where you might want to use the example I just had is if you had like a entity framework or some sort of JSON or an XML file coming down from your server, and you want to generate a proxy object. That example I just did is probably very good for that. Like, you don't want to have to generate those by hand. You might be reading in from your latest server definition, and you just want to generate the proxy, and you want to just automatic part of your project. So you don't want to have to do extra steps. That's where this kind of source generator is really useful. So then you're just updating one XML file, one source of logic, and it's automatically included in the source generator project. And once they fix up the Intellisense issue, it'll be really powerful, right? And in the earlier versions it was. It's just been broken in the latest version, unfortunately. But I can go through another example that's sort of like more beefy in terms of another practical use for people in sort of like the WPF and Xamarin space and that sort of thing. I can go through like a source generator for identified property change. I find that pretty useful as well. So let's go through that example, and then if people have more questions, we can bring it up. So I'll just do whichever one was working. Let me find out which one was working. So let's see. Let me close down the other Visual Studio instance. So I'll share that one. All right.
Got another question here in the chat, if it works now. Is this why there are two projects? It isn't available in the project that generates it, but it is in the project that you're referencing it from?
Yeah, so think of it like a Fody, right? You will reference in a separate Fody from what you're generating. And it's very generic source code. So it's very much, like you might want to reuse it everywhere, right? So it's very much meant to be plug and play. So it's meant to be, you find a NuGet package that suits your needs, you'll plug it in. So if we do a share on the you know, Fody, and I'll just swap over to that for a sec. And we look at, we go to the home section of that. You can see here they've got a lot of Fodys available. So if I zoom that in a bit for you guys, you know, like they'll generate properties for you automatically, or they'll generate caseless string by default, or they'll do the equals generation for you, so you don't have to do it yourself, or they'll make the equatable for you, or you know, they'll do the JetBrains annotation for you, and they'll automate everything around a lazy. The main advantage of source generators, once the IntelliSense issues is fixed, is you get to work with that generated code automatically. You get to interact with that. You don't have the problem of they'll come up in IntelliSense and they're actual objects as far as you're concerned, so you can interact with them. Well, with Fody, it's after the fact. So with Fody, there have to be things that kind of like modify your code that you don't rely on. So I'll give you a good example of that. So with the property change one, let's have a look at their example, right? So they get you to put into your, bring in a NuGet package called property change.fody and see how you notify property change, fairly good code. And they get you to do these gets and sets, right? And what Fody does is it goes behind the scenes and goes, oh, okay, I see this given names, I see this family names, and I can see that's a property. And it doesn't have any implementation of the get or set. So what I'll do is I'll go generate this code behind the scenes, right? So I'll go off and I'll modify these given names and then basically do these gets and sets for you. But the disadvantage of the Fody approach is you can't rely on that code in your project, like all those properties I generated. You have to modify something already existing that then will have a new effect on it. So in this case, you have to modify existing code. If you want to use that person, the given names, because we can use this in this case because it's got an identified property change, we can use that artifact, but we can't rely on any modifications to that code because it's done after compilation. So, you know, like we can't rely on given names and then generate code based on given names, for example, and then rely on that code in your project because it's already after the fact that the compilation happened. So we have to modify code. That's where source generators are quite useful. So I'll give you some examples of that in a sec with the identified property change. I'll probably clarify that a bit more. So let's make one and then we'll go through the process of sort of like clarifying what I mean there. So what I'm going to do is I'm going to make one based on property change. So let's go into we can make another project, but let's just keep the same one going. So you can chain multiple generators into the one project as well. So let's call it auto notify generator. So this will generate the notify property change. Let's make it public, and we'll again derive off iSource generator. And we'll tell Visual Studio it's a generator, right? So we'll have to import that class in probably. It's happy. So we'll implement our interface. Cool. So in this case, we're going to generate our sort of like notify property attribute. So this will be on top of classes we want to generate our identified property above, right? So what it would be sort of like, and we would have, so this will be our attribute we put above it, right? So, and the nice thing is you can put all the boilerplate code in your generator. So we'll effectively inject this into your project, and you can put these above your classes after the first compilation. So you don't have to have separate projects like Fody does. Fody will have two DLLs per project, one with all the code you can actually use, and another one that does all the weaving in our case, we can include it as part of the generator, which is quite nice. So what we want to do is we want to register ourselves that we're going to receive source generation. So we're going to say, hey, I want to be told when our syntax is changed. So basically when people are typing in the code base, I want to be notified when that happens. So, you know, Intellisense is kind of like doing predictive text. So I'll give you an example in a sec. So let me just bring that in. So if we do context dot, and we modify in the code, and C# bringing a little green wriggly stuff in, that syntax receivers basically say, hey, I want to be notified when the that's being imported in. So I have to, give me a sec. I have to change the project, bring another project in. Does anyone else have any questions? Have I lost people, or are they still with me? What's the general consensus?
Looking good to me.
So we're just bringing the lights bigger. Doesn't have to be. All right. Let's see if that will be happy now. Does it compile? Visual Studio has been a bit funny on me, so can't find it. I can always bring in another version of this I did again. Okay, I think it's part of the context. I changed it recently. All right, let me find the version I did previously, and then I'll bring it in. Sorry, guys. So let me go through all the code. I'll put it up, and then I'll fix up the sort of like the compile errors like this, just so you get an idea of how it's working, and then I'll bring in a fully compiled version for you guys, just to keep things rolling a bit.
Got another question here from Ryan. Do you know if you can use source generators when using Rosalind directly? Like if you have created an in-memory compilation, can you run a source generator over it?
I imagine so, because it's just another Rosalind analyzer, right? It's hijacking the analyzer project, basically.
Cool.
And by the way, feel free to put your mic on, guys, and talk as well. All right, so what I'm doing here is I'm basically, whenever I've got a new project being compiled, I just put this attribute in the code for the person, right? So I'm going to go, okay, add the source of the auto notify property changed, and sort of like add that attribute in here. And then we're going to say, unless there's a syntax receive, and the syntax receive is basically telling me, hey, there's source code happening. So unless we have that, you know, like, because we might have examples like last time where we want to generate based on XML files, but in this case, we want to have .NET code. So what this is saying, only get to this point if there's .NET code coming in. And what we're interested in doing is, this is where we're kind of going to do some sort of like C# compilation. So we're going to basically grab in the C# compilation option. So we're going to grab in all the options from C#. This type of code, you know, you kind of, a bit glue code, you kind of do it, you know, once per project. And then we were interested in, so we're kind of setting it up so we're kind of getting properties from our class. So we're interested in, we have an auto notify property, auto notify attribute. We get that instance from our source code, right? So we're just doing standard reflection. We're just getting that token from the compile code, right? And the other one we're interested in is the I notify property chain. So we say, hey, compilation, give us that instance. Because what we're going to do next is we're actually going to look through all the classes in our code and find classes that implement both identify property change and that have fields that are called, that have the auto notify attribute above. So because the source generators generate source code, they don't generate properties. Sorry, because, let me rephrase that. Because source generators generate code, they can't modify code. We have to sort of like, for the identify property change, we do it back to front and what you do in a Fody. So in the Fody, you would do, like public string, and you just do an auto property, right? And what it would do is it would modify this code and go, oh, okay, you got to get and set there. Let me just modify that so it has a, you know, and let me modify it so it has, you know, a standard pattern, right? But because we can't modify code in the source generator, what we do instead is we will do it this way. And what the source generator does is it generates this for you, right? So it generates the standard notify property change pattern, right? And the nice thing is, at least until the most recent version of the Visual Studio IDE, is you can interact with that from Intellisense. So it's just a different way of looking at the same problem. But you're kind of doing the inverse. So if you look at the two different ways, in the source generator way, you just do a field in the, because you can't modify a property like that, right? So you can't modify our source code. You can only generate code. Well, in Fody example, it can modify code. So that's where Fody still have its place, because there's certain cases where you might want to still modify code. So what I'm setting us up for at the moment, though, is to kind of like go in here and you know, find anything that has an auto notify attribute above it, and also implements an notify property change. So let's set that up. So if we go back to my sample code. So what we're interested in doing is we have a receiver. Let's fix this issue, by the way. There's got to be some reason for it. I guess I changed it recently. It's all the same. It's only too fancy a version. Come on. Otherwise, I'll keep going and just use a sample, but let's keep going. So what I'm going to do is I'm going to go through, find a list of fields that match the paradigm we're interested in doing, right? So we've got this receiver. The receiver will have, actually, I know what it is. So never mind me. I made a receiver object. So we have to implement, so I syntax receiver gets told about nodes in your source code, basically. So you have to implement that. And you have to say, we're interested in nodes that are fields and they have an attribute list above 0. So if I have an attribute and they're both in a field in a class, we want to add them to this list called a candidate field. And now we can modify our code here. Cool. That explains the issue. Cool. So basically we're only interested in if it matches our own generated receiver class, right? So the receiver class is just basically IntelliSense saying, hey, code's changed. What are you interested in about this code? And so it tells you about all the different nodes in that code. So you'll say, hey, I'm interested in fields, and I'm interested in fields where the attributes of the list is above 0. So now we got these candidates, right? So we got the candidate fields that match. They've got an attribute and they're a field. So that's cool. And now we go into here and we kind of like will grab, there's a lot of glue code in here. So what we're interested in now is we get told about the actual source code. We don't get told necessarily about the actual reflection version. So what we want to do is get the reflection version out. So what I mean by that is, if you look at a field, it tells me about, like the modifiers on, it tells me the source code. So it tells me, here's a public modifier. Here's the, here's the name of it. Here's a semicolon list, and here's the attribute, right? So at this stage, we don't really get to know about, oh, here's the base class, or here's the class that owns it, or anything like that. We just get to know about the source code, basically. But we can get, but analyzers get past what's called a, the context and then the compilation. So it gets told about all the codes that's been compiled, and the compile knows about all the different classes and all the different fields. So what we're going to do now is we're actually going to get the compiled version of this that knows a lot more information. So if we get our I field from our variable, oops, sorry. Let me copy paste some code in. So we have a variable in here which tells it where it's been declared. So each one of these fields, and then what we're interested in is we actually get the declared symbol. So at this point, if you look at a I field symbol, we get to know if it's const, we get to know if it's read only, we get to know what type it is, and we get to know, where it's come from. So if we look at the type symbol, it'll tell us, like a whole heap of extra information we didn't have previously. So it knows what the base type is, knows what interface is implemented. So if you think about the syntax is just, here's what the raw source code is. And at this stage, we were interested in the actual reflection information. So now what we're interested in knowing is, hey, does this implement our auto notify attribute for us? So we're interested in knowing, we've sorted off, we're interested in if it matches, it has in its attributes, something that matches that symbol, right? So that guy there. And so if it does, we add that into our list of field symbols we're interested in. So here's all the candidates. We're going to grab all our candidates and sort of like work it out from there. So then what we can do is we can basically group the fields by the class so we can generate some source code for it. So what we're interested in doing is we're going to group based on the type. So we're going to put all the related fields together. So if you think about this, let me just do some raw source code for you guys again. Let me do it out here. And we'll do another one. Right, so what it's doing now is just standard off-the-shelf link code. It's going in and grabbing the containing types of the class, right? And then it's grouping it by that because we just get a bunch of fields. At this stage, we get all the candidate fields. We just get told about all the fields in the project, and they're not grouped by class. We want to actually generate it as a partial class for every class so we can do our unnotified property changes. So that's all that's doing at the moment, is grouping it for us. So we know all the ones in this class and then all the ones for this class, groups it by instance for us. And then now we're getting back to the stage where we're going to deal with source code again. So I've given my, I'm just going to have a private method in here. I'm just going to pass in my class object. I'm going to pass in all the fields we want to generate unnotified property changes for. We get told about the attribute that's on top of the class. We get told about the identified property change class instance, so it knows to look that up. And we also just pass in the source generation context so we can add code in there, basically. So now we're interested in, by the way, all this source code is available free online. So we're interested in making sure it's not the default namespace. So basically, if there's a class sitting by itself without a namespace, don't bother processing that. And we want to grab its namespace so we can know where to generate this code. So we're just going to grab from the class, its containing namespace. And so this will be, you know, it will be that portion, the abc.abc2. So we're just going to grab the namespace. And now we're just going to do a string builder like we normally have. So if we look at, we're just going to grab a string builder. And now we're dealing again with, there's a lot of extra code in here. You could simplify this a lot, but you're kind of just building up your namespace. You're building up your partial class. You're putting the identified property change in. So this will be changed to, you know, system.component.identified property change. So we're going through and we're basically generating partial classes for all the different classes. And so we're going to make sure that the class, if it doesn't already, implements identified property change, right? So it'll put a property change event in there if it already doesn't contain a property change event in there. And then we'll just go for each field we found. And we're just going to generate some source code for that. We're going to pass in our source code string builder. We're going to pass in the field and the attribute. And then we're just going to generate closing brackets, right? So pretty easy. And now we'll just do the process in the field. So at this stage, we're just dealing with reflection, right? And we're just dealing with a sort of like standard off-the-shelf code, right? So I've just put stuff in. So let's go through it. We're going to grab the field name. We're going to grab its type. We're going to go through the attributes, and we're going to find the attribute that matches that matches our attribute up here. So it's going to match the auto notify attribute that we generated, and it's going to find the property name because you might want to override the property name with your own. And it's going to go, well, if we've got an attribute, we'll use that as a property name. Otherwise, we'll just use the code in here. So we'll put that in a method. So what this is just a standard off-the-shelf method I've generated that goes in and picks a name. So what it does is by default, what it does is it strips out the leading ampersand there, and it capitalizes the M. So then it becomes and let me make it a nice name. Okay, cool. So then, you know, as long as the property name actually has a value, great. The property name has to equal the field name, great. So, you know, like if we somehow generate a field that matches the same name, well, that's not going to work, right? Because we can't generate a field that matches, I can't generate a property that's the same name as a field. So we can't do anything at this stage. But now we're just doing standard off-the-shelf code, right? So now we're doing, again, pending to our source builder, which is going to return the field name, or otherwise we set the field value. We can add an extra step in here. So we can add our, you know, if checks in there. And this should be all code you're kind of familiar with, right? Because it's sort of like, it's sort of like, you know, we're setting the field to the value and then we're invoking an identified property change and we're passing the name of the property, right? So if we combine all this together, if we go back to the higher level, bit of boilerplate code that you kind of reuse, we find the attribute, we find our identified property class or interface, sorry. We just get a list of fields. We make sure we can get it into a format we can deal with so we can find the the class it belongs to. And then we just add those in. Then we just group it based on the class. So all the fields of a common class get grouped together. We just generate a bunch of partial classes. And then we go through all the fields on the object, and we just then generate a bunch of code, generating our public getter and setter, right? So a little bit involved, but once you ignore that part, you know, it's pretty much reflection code with a bit of source generation, right? And basically this source generator is done now. So in theory, we should be able to go into over to here and generate a new class. And again, we're probably going to have a right. So we have to make it a partial class because it's going to generate the code for us. And of course, you can't play up a bit. So what is it in component model or something? Yeah, that's cool. So we just generate our, that would have been generated for us, but that's cool. So now we just generate a, and now we just want to do a using statement. So we just want to bring in that namespace in. So we go back to here. Of course, we'll complain about, and then we just do auto notify. And now if we generate, and we do and we'll just do my field. And then we can just do we change event, which is generating the line. And then I'll just do a lambda, I guess. Well, I'll just do and then we hope that this all compiles. The bug. And I bet you, oh, there you go. First row rank, and I'll run it and I'll show you the output. And because I need to change that, 1 second. Okay, let me show you the output. So you can see here now, we told it to output hello world at the beginning. Let me share the inside screen so we can sort of see it all. And let me change the font on that too if I can. Can you guys see that, or is it a bit small? Oh, there we go. I can zoom in. So if we look at the source code, we got our my class. We did a property change. We changed the property, and then it outputs, hey, the property's changed. So that's how you could do a identified property change. Does anyone have any questions on that one?
With all the code you're kind of writing as part of your templates,
Yeah.
you're kind of putting quite a lot of C# just in strings with no type safety or IntelliSense or anything like that. Is there any way to have the compiler and all that lovely C# stuff help you out while you're writing your templates?
So in terms of the, this guy here,
Yeah.
you
So
can use Rosalind or code DOM. So I'll give you an example of that with some projects I've worked on.
cool.
So let me.
Because I don't much like the sound of writing all of that with no red squiggles to tell me that there's something wrong in my template.
Yeah, I mean, you could just do, the problem is you've kind of limited, right? Because you are generating code. But let me go in another example of a project I've written where I've done a lot of C# generation. So this is a project that's part of Reactive UI called Pharmacist. It generates a bunch of code, observable codes for you for reactive extensions. So observables are, think of a link object for an event. Effectively, you can do where statements. You can say, I want it on this thread, a bunch of extra nice code. And we wanted to kind of like generate a layer around events, right? So Pharmacist kind of generates all the observables from events. So you can wrap an event, you can wrap an observable around an event. So if I go into some Rosalind code, and this will be similar to code DOM and stuff people have done in the past. It's not too fancy, but you're dealing with this type of code. So you're dealing with like class declaration, with modifiers, with leading trivia, and then members, and you're kind of building up a builder style code. So this is the way Rosalind works. So for example, here would be, we create a class called events extensions. We put the public and a static keyword on it. And we put a comment above it. And we go for each declaration, which I've extracted previously in the code. And we go, oh, okay, put a class name on here. So it's going to generate a class. Okay, generate a method on here called the event class name plus the events. And again, we're going to put public and static keywords on there. And then we're going to have parameter lists. So, and with modifiers. So if we think about the code, I put, a lot of these cases, I put what's been generated here. So it might be a public static class event extensions. And I've done it more in other areas, but yeah, so you can use it like this sort of like very event orientated way of doing it. So for example, here, you know, like here it produces a local function. So you have, it returns a void, has a name of handler, has two parameters, so data type 1, data type 2. We'll then pass it to a delegate called event handler, passes those parameters along. So it becomes very builder-like, and a nice project that you guys might not have known about, but I'll show you now. If I go back to my, sort of like my source code here. There's this project called Rosalind Quota, which is really nice. What you can do is you can kind of, I don't know, you can put in code in here that you want to generate Rosalind builder code around. And what's really nice about it is it then generates that builder code for you. And this is the way, you know, like with that, where I was kind of wanting to get away from source code in that auto notify property change before, and I wanted to get to the compile code. This is sort of like what it looks like when C#'s generating a bunch of code behind the scenes. It's generating all these from this code. It's generating this builder for you. And the nice thing about builder, you do get compile time warnings and stuff, and it's to get the code out of here. So if I bring this in to I'll just bring it into a project so you can see what it looks like. And then we'll go from there. So I'll just make a new, you know, like I'll bring it into maybe just make a new project quickly. And we'll just do a console app. And I don't really care what it's called. And I will want to bring in my C# code analysis. So I'll bring in this code. So I just want to bring in the C# Rosalind code. And then I want to basically in here, just want to generate all my, bring in that source code we had, and then using system. So we'll have to bring in the C# code. So I just need to get the right NuGets in. So I'm just doing that quickly. So if we put another one in. And then we just do, you know, and we just need to bring in the right namespaces. So, okay, we won't bother with the normalized space then. Okay. So we can do a full two string. So that allows me to generate now from that builder. If I now share my console prompts, it puts in a very condensed format, but you can see there it's generated that code, put in a C# code for us. Now, if I go back to my C# instance and I do what's it complaining about? Oh, I see. We need to there we go. Just a namespace missing. So if I run that again, and I go to share that output with you, you see now it's just normal C# code. So that's probably how I do it, or with CodeDOM. But it's quite nice to have a at least have the builder style C# generation to get past compile errors and stuff. Yeah, so that, I don't know if that fully answers your question, but in terms of actually using proper C# code, you could probably also, another way you could do it is Rosalind can reverse engineer from C# code. So you could probably have like, if we go back to our analyzer instance for a sec. So if we go back to our demo, I could probably in my, I think this is the wrong one, but yeah, let me go back to the one with the, if I go into here and I go, you know, do my auto notify property, I could potentially copy paste this across, right? And then I could probably include that, you know, I could use Rosalind or something to read that in. So that's another way I could possibly do it. So you can actually tell Rosalind, I've got this source code on my own project. Do you mind reading this as source code? So that's potentially another way you could do it. Either would work. Does that answer your question?
Yeah, I like the sound of the second option as long as it's not too many hoops to jump through.
Yeah, I mean, in terms of the hoops, it would probably be just sort of like, I'm just trying to think. Probably the easiest way is just to read it in. Maybe even have a second project and just do a file.read and just do it that way. It's probably the easier way to do it. So I'll just read in that source code. So I could even just do like, you know, file.read ... / whatever, or something like that, I don't know. Or just include it as a embedded resource. That's another way you could do it. So you can compile it, but then use Rosalind to get it out. So you can do stuff like that, and it shouldn't be too much work, but it'd be a little bit of thinking on my part to write it up right now.
Fair enough.
So questions, and what do people think of it? Is it overly complex for your needs, or is it something you would use?
I think, Glenn, that I'm not too sure I use the source generator. I can't see that, but certainly the stuff you're talking about there with Rosalind, I use, as I mentioned earlier, I use CodeDOM.
Yeah.
But the Rosalind by the sounds. so the second stuff, I'm certainly moved to Rosalind now. That's pretty cool what you were just doing.
Yeah, so the advantage of Rosalind is like over CodeDOM is supports newer C# syntax. Has great tools like that, Rosalind quota. So you could take, when you're developing this code, you can sort of like quickly just put in Rosalind quota, get the builder for yourself, and then build it from the builder. It also can be a little bit faster than the old CodeDOM. That's another advantage. But the source generators, I think where I'd use them, it's not necessarily like that I notify property change one. It'd be more like, hey, I want to automatically import this the web service in from its JSON code. I want to generate a C# code from that, or I have my own database mechanism, and I want to, it's generating XML, or I can get code for it. Or another good example is I want to make wrappers around my classes. So I want to sort of like, I got my model and I want to generate a bunch of view model supporting ones that do I notify property change. You could read through all the properties on your model and then generate your view models automatically. So that's enough. You can generate whole classes. And another example where I'd probably be using is in project of mine is optimizing source code in terms of I would have expressions that would generate, you know, like I'd read into where it points towards a property. So for example, I want to, I'll give you an example. Let me share just my notepad. So in reactive UI, it's very common to kind of like have code like this. So I'm just going to make this a bit bigger for you guys. So let's make it 20 or something. So, and we derive off the reactive objects, and we would have a so, you know, I could have that automatically generate a, you know, like a, so it automatically would generate the gets and sets and the I notify property change, right? But quite common in reactive UI is we're interested in knowing when the properties change and do it in a nice link style format, right? So I've got a newer project called, so we could do, this is a syntax that's used in my current sort of like optimized version. So people that actually use reactive UI are more used to when any, but I've changed it to when property changes. So now it's a link statement, right? So we can say, let's make it nice and easy. So, and then I want to subscribe to the event with the value, and I just want to output to the console, right? Something like that. So what this says is when that property changes, when the value is equal to test, output test to the window. So this part is actually an expression. So this is nice in terms of it's using a link expression. So behind the scenes, it's actually it's actually an expression, and expressions are compile time. You know, I can have a reflection cost. So basically, they give you the ability to interrogate all the objects along the way. So you can do like a for each. And so you can see, you know, like if I change this to be, instead of my property, like x dot, each one of these objects will be given to you when you use an expression, but it's using a reflection to get that information. So it's going object one, object two, get my notified property, right? So let's pretend you have, you know, here, right? And it's subchaining it up. So in another, in your, you would have this would be your object 2. And then right, so I bring that down, and what this refers to is go on my current object, go to object 1, so go here, and then, which is this, and then go to object 2. And okay, go to object 2, and then finally get this, and basically subscribe up to the I-notify property changes and tell me whenever this object or this object or this object changes and all values are available, right? And what it uses behind the scenes is this thing called expression, which allows me to get each object every time and then subscribe up and then get notified when the property changes. But what I can do now, instead of doing expression, I can just generate, I can just make this a func, which has no compile time, is only compile time. It doesn't get to know about any runtime information. And I can go off and sort of like set up a bunch of code here to optimize this. So I could sort of like say, you know, subscribe to when object 1 changed, and then generate a bunch of code in here when object 2 is changed, and do a bunch of glue code that you never want to know, and optimize this so it's compile time aware. So that's where it's probably an advanced usage, but that's probably where I'll probably end up using it, where I can kind of like, instead of making this all runtime and slow and having to know about all the different objects at runtime and interrogate, you know, through reflection, I can make everything happen at runtime, sorry, at compile time. So that's where it could be pretty cool. So that's a bit more of an advanced usage, but for the general user, it'd be like databases, notify property changes. And what will end up happening is people will make a bunch of these and you'll probably subscribe to them. But if you want to make your own, it's just easy because it's C# code. So. Does that make sense? I probably lost a few people on the advanced usage, but
I get the idea.
you get the idea.
Just trying to think of usages for it. What sort of things do you reckon it will be used for, mostly, Glenn?
Let me go into the samples I have in the SDK. So some of the ones I have is sort of like generating code from CSV files or generating settings. So you have a settings XML file. You want to generate classes to use them. You could do some of the advanced stuff I'm probably thinking of doing, sort of like, I've got a XAML file in my Xamarin Forms project, and I want to auto-generate the razor files from a Blazor project. I could generate all the razors automatically. So it doesn't have to be C# code to be in the file. And I could generate my code behind. So I've done that sort of code before for another client. And this would be sort of like taking that and sort of like auto-generating their XAML, their razor files from the Xamarin Forms. So that could be cool. You know, some of the traditional Fody style stuff could be done in it. So, you know, like generating, you know, like toStrings and equals and all that kind of stuff. So you could sort of like say, hey, you could have an attribute you put above different properties, and that could be in your equals. You could say generate, you know, timers and things like that. So where it automatically invokes your code.
Mm-hmm.
All those sort of things, or you could get source control information and stamp it into your project. That kind of
Sure.
stuff.
And you can generate any type of file, right? You could create XAML files if you wanted.
Yeah, that kind of thing, yeah.
Cool.
So yeah, it's got uses. It's just sort of like, I think the main limitation is just the preview at the moment. So it was a little bit hard to show you without Intellisense working, but in preview 3 of Visual Studio, it was working 100%. So it's basically any sort of like thing you potentially would glue code or things you kind of repetitive. It's pretty easy, pretty useful. But yeah, that's basically my presentation. Just took you through a few different examples, and you know, hopefully at least you know how it works, and when you see people make them, and maybe you generate your own where it's useful.